So we have region B right here. Region C right here, right?
Mm-hmm.
Sorry. Region A and region C right here, right?
Right.
This is our arrow, right? We spin it and we're asking what's the probability that this arrow will stop in this region, in region C, right?
Mm-hmm.
So this arrow must stop somewhere, right, on the spinner. It must land somewhere.
Mm-hmm.
So what does it say relating to our probabilities? So if the arrow must stop somewhere, what would P of A plus P of B plus P of C equal to, right? What, in other words, P of A means probability of arrow stopping at A, P of B means probability of arrow stopping at B, etc. If we know that arrow must stop somewhere, what would this sum equal to, do you think?
Should it equal to 1?
Okay, why do you think so?
Because number 1 could represent, how should I say, maybe definitely probable, like
Correct.
event.
Yes,
It
yes.
represents that anytime you spin a wheel, it either goes to A, B, or C, and it will always, hit that spot somewhere.
Exactly.
And 1 could represent that.
Yes, yes. So in probability, remember, it's a number that describes the likelihood of an event from 0 to 1, where 0 means the event is not happening, and 1 means it's definitely happening.
Mm-hmm.
So yes, since it must land somewhere, the sum of these probabilities must equal to 1. And do you have any ideas how to find P of C given that information?
Well, now it's, I think, more simple. It's like an equation, and you just, since we know that A is 1/3 and B is a half, we just subtract.
Why don't you guide me so that I
Yeah,
write down so that it's easier for us to solve it? So what should we
right.
write?
So B of C equals to 1 minus, and the parentheses, 1/3 plus 1/2.
Mm-hmm. Okay. What do we do next?
We have to sum those values in parentheses first.
Okay, guide me. What I should write?
So 1/3 is basically, I'm trying to, because they have different denominators.
Mm-hmm.
So the common multiple 3 to 2 is 6.
So 6 is the
6 is denominator.
common denominator, right? For
Yeah.
those fractions. If we want to sum them up, remember from algebra,
Yes.
we need a common denominator. So what do I write here in this parenthesis?
So we would write 2/6 plus 3/6, which is 5/6. And 1 minus 5 over 6 is the same thing as 6 over 6 minus 5 over 6, which is 1 over 6.
Correct. Okay, yeah, that's exactly right. That's our correct answer. And we sort of visually see, right, that it's small, so it's it confirms our intuition. 1 over 6 confirms our intuition.
Mm-hmm.
But just as a reminder, those areas may not necessarily correspond to the areas shown right here, right? So in casino, for example, you may have a game, you may have a spinner where areas are equal, right? Where we have this situation, but it is programmed in the way that P of A is 1/3 and P of B is 1/2. Does it make sense? P of C is 1/6. So it may be programmed this way. This arrow may be biased, So it's important to understand that this is just a visual sort of diagram for our understanding, but this is absolutely fine as long as we remember, we're showing probabilities, right? We're not necessarily saying that these are the areas, the corresponding areas of a spinner, right?
Mm-hmm.
Any questions? Does it all make sense?
Yes, I think it does.
Okay.
Yes.
Good. Okay.
So actually, I have a question.
Sure.
You were saying about the casino, how it similarly looks in real, circumstance, like a spinning wheel in casino. And are you saying that the mathematical probability is not necessarily the same thing as in casino when we spin a wheel? Or you said that the arrow may be biased, as far as I understood, right?
Yeah, so if we have a spinner, do you know what it is, like a spinner?
Yeah.
You have a spinner, and there's this arrow, and you spin the wheel, right? And then it stops spinning, it slows down, right? And the arrow points to some area at the spinner. Like in the Russian TV show that you must remember, Что, где, когда. Remember, they spin the spinner, right? And it lands somewhere, right? Lands at a question, Arhangelsk, right? And a question from a TV fan, right? So in the same way, that's what they're talking about, right? The spinner. So it's divided into some regions, and you spin the wheel and the arrow stays here. It's stationary, but the wheel keeps spinning and then it stops, so the arrow points in some area of the spinner. Does it make sense?
I see. Okay, yeah.
Okay. I think, yeah, that was the problem. You didn't understand what the spinner is. Given that, now do you see what I was talking about here? Like the potential areas of the regions A, B, and C. It doesn't necessarily mean that the spinner is divided exactly as shown here, right? It may be different, but the spinner may be biased, So we must distinguish between mathematical probability and the areas, the surface areas of regions. It may not necessarily correspond, the mathematical probabilities and the surface areas of the regions. Does it make sense?
Yes.
Okay. Okay, well, that's about it for today's class. Thank you a lot for being here, paying attention, asking questions, and I'll see you next time.
Yeah,
Okay.
thank you so much. Have a good one.
Yeah, you too.